Hello students, in this video we will discuss about solution of exercise 12.2 from the chapter Heron's formula. Today in this video we will discuss about only one solution of question number 3. So let's check the solution. Radha makes a picture of an aeroplane with colored paper as shown in the figure. Find the total area of the paper used here. Okay, so as you can see, this is the picture of the aeroplane. Now we will divide this picture in 5 parts. Okay, look at here. If you look at this diagram, this first one is part number 1. Okay, this rectangular one is part number 2. This trapezium one is part number 3. This triangle is part number 1 minute. This triangle is part number 5 and this triangle has part number 4. So first of all, you will find the area of these 5 parts separately and then you will add it so that you can find the total area of the paper used to make this aeroplane. So let's start with the solution. First of all, we will find the area of part 1. Okay, if you zoom it, you can see the dimension of this triangle is given. The side as 5 centimeter. And since this one is 1 centimeter, this length is also 1 centimeter. Okay, so in part number 1, this side is 1 centimeter. This side is 5 centimeter and this side is also 5 centimeter. Okay, so to find the area of this part, you can easily use Heron's formula, where A is equal to 5, B is equal to 5, C equal to 1. Find half of the perimeter, it will be 5.5. Put it in the formula of area of triangle. Okay, now if you do the calculation, if you put the decimal value of root under 11 up to 3 decimal places, it will be 3.317. In the previous video, I have explained how to find the decimal value of a rational number, approximate decimal value of a rational number. So if you want to recall, suppose you want to find the decimal value of root under 11 up to 3 decimal places, just use long division method. 3 3s are 9, right? 2 will be here. Put a decimal, here will be 2 zeros. Now here it will be double of 3, that is 6. Now how much you have to put here? Okay, so if you put 3 3s are 9, 18. If you put 4 4s are 16, 2 5 6, which is more than 200, so here is 3. So it is 1 8 9. Okay, so 1 1 11. Again for this decimal, here will be 2 zeros. And what will be the value here? Okay, it will be 3 into, okay, 1 minute. When you are putting here 3, here will be also 3. It will be 33 into 2. That is the number without the decimal. That is 66. Put here 66. Okay, now how much you have to multiply, so that how much you have to replace here so that you can do the calculation. Okay, as you can see, you have to put 1 and here also it will be 1. Again it will be 661. Just do the subtraction, okay, in this way. So you can use 3.31 in place of root under 11. Okay, as you can see, they have used 3.317. You can use 3.31 and if you do the calculation, this will be the approximate area of part 1 only. Now we will find the area of part number 2. If you look at the previous slide, the part number 2 is a rectangle, okay, whose length is 6.5 centimeter and breadth is 1 centimeter. So in part number 2, length is 6.5 centimeter, breadth is 1 centimeter. So what will be the area? The area for the rectangle is length into breadth. So 6.5 into 1, that is 6.5 centimeter square. Okay, so you got the area of part number 2. Now part number 3. Again look at the previous slide. Part number 3 is this trapezium. So how can you find the area of this one? If you zoom the trapezium, this side is 1 centimeter given, okay, and this side is 2 centimeter given. Now how can you find the area? As you can see here, AD is already parallel to BC. You need a construction. What you will do? You will draw a perpendicular AE on this BC, and also you will draw a parallel AF which is parallel to CD. So what are the construction? You have to draw AF parallel to CD and you have to draw AE perpendicular to BC. Okay. Now since this CD is equal to 1 centimeter, AF will be also 1 centimeter, and since this AD is 1 centimeter, this FC will be also 1 centimeter. Okay. Now if this is 1 centimeter and total is 2 centimeter, that means BF is also 1 centimeter. BF is also 1 centimeter. Now if you look at this ABF triangle, this side is 1 centimeter given. This is also 1 centimeter since CD is 1 centimeter, and this is also 1 centimeter. So three sides having equal length. So ABF is an equilateral triangle. And this perpendicular in equilateral triangle, this perpendicular on third side will be a median, that is this BE, or this E point is the midpoint of BF, or BE is equal to 1 by 2 centimeter, that is 0.5. Okay, so now you got this side as 0.5, this side as 1, and this is a right angle triangle. If you take AEB triangle, this is a right angle triangle where this value, hypotenuse value, and the base value is given as 1 and 0.5. So by using Pythagoras theorem, you can find the value of AE. Look at here, Pythagoras theorem states that AE square plus BE square is equal to AB square. Okay, now put the value of AB and BE. You will get the value of AE as root under 0.75 or 0.866 centimeter. Okay. Now the area of trapezium will be half into sum into parallel sides into the distance between them. This is the formula for area of trapezium. Half into sum of parallel sides, that is half into AD plus BC into distance between them. The distance between them is AE. Okay, so just put the value half into BC plus AD into AE. Put the value. This will be the area of this total part. Now you got the area of this part, this part, this part. Now you need 4 and 5. As you can see, the area of 4 and 5 is same because their dimension is same. In 5 the dimensions are given. This is 1.5 centimeter, this one is 6 centimeter, and as you can see they are perpendicular to each other. Okay, so if you check 4 and 5 part number 4 and 5, you can say that this triangle is a right angle triangle, and for right angle triangle the area will be half into base into height. Base is 1.5, height is 6. Just put the values here, do the calculation, it will be 4.5 centimeter square. For both part number 4 and 5, area will be same. So what is the total area for making of this aeroplane? It will be area of first, second, sum of area of first, second, third, fourth and fifth. Just add these areas. That means you have to add this one for the first part, this one for the second part, this one for the third part, this one for fourth and fifth part. Just add them, you will get 19.287 centimeter square. In this way you have to solve question number 3. This question is a very important question for 4 marks. Okay, just study it very carefully, check it very carefully and practice it. As you can see, there is so many steps. First of all, in first step you have to convert irrational number to a decimal expansion. Okay, in second part you have to find the area of this trapezium. You have to use Pythagoras theorem here. Okay, you have to use area of trapezium here. And for second, fourth and fifth part you have to use the basic formula of area of triangle and rectangle respectively. So this is all for today. Thank you.